I'm teacher Gina. I'm going to discuss today about conversion of units. What is the importance of conversion? Why we need to convert one unit to another? We need to convert one unit to another, especially in the unavailability of a particular unit in a measuring device. Like for example, you are asked to cut 10 inches long yarn and the available measuring device is a ruler. A ruler containing centimeter scale and millimeter scale. There's no inches scale available. That is why we need to convert. We need to determine how many centimeters are there in 10 inches. There are different system of units available worldwide. We have the imperial system of units, the US system of units, the metric or the SI, and the British or the English system of units. But we're going to concentrate only on this two system of units, the metric and the English. So let us start now. Let us first convert metric to metric, then metric to British, and British to metric. Okay? So suppose we have here 28 kilometers. How many centimeters are there in 28 kilometers? Again, how many centimeters are there in 28 kilometers? As you have noticed, the metric system is popularly known on its prefixes used. There are lots of prefixes used in order for us to know how large or how small is a certain measurement. Like for example, deca. Deca has a value or a factor which is equal to 10 raised to 1 or 10. Hecto, 10 raised to 2 or 100. Kilo, 10 raised to 3 or 1000. Mega, 10 raised to 6 or 1 million. Then giga, 10 raised to 9. Tera, 10 raised to 12, and so on. Then for the smaller values, we have deci, 10 raised to negative 1. Centi, 10 raised to negative 2. Milli, 10 raised to negative 3. Micro, 10 raised to negative 6. Nano, 10 raised to negative 9, and so on. So we can directly or easily convert metric to metric, especially if those measurements are associated with prefixes. So let us just use the smaller one. Start with the kilo, the hecto, the deca. We have the deci, centi, and the milli. Okay, and let us write here the base unit. We have here the base unit. Okay, so the base unit here is meter, the unit for length or distance. Kilo stands for 10 raised to 3 or 1000. In here, the same, the base unit is meter, then the prefix is centi. So how many centimeters are there in 28 kilometers? So take note that in metric or the SI units, this unit or system of units introduced the 7 basic or fundamental quantities. We have the length, mass, time, temperature, amount of substance, electric current, and the luminous intensity. Got it? Okay. So in converting this example, we have 28 kilometers to centimeters. So we're going to count only the number of decimal places. Okay, so from kilo, we have here from K. So start with K, then to centi. So how many places will be moved? 1, 2, 3, again, 1, 2, 3, 4, then 5. So there are 5 decimal places from kilo to centi. So therefore, we're going to move the decimal point, the understood decimal point. So where is the understood decimal point for this number? 28 kilometers. Of course, it is located at the end of the last digit of a whole number. So we're going to move 5 places. 1, 2, 3, 4, 5. So therefore, copy 28, then add 5 zeros. So this is now, okay, so we have 2,800,000 centimeters. Again, there are 2,800,000 centimeters in 28 kilometers. So we're moving from K to C. 5 places to the right. Next, how about this one? 48,600 milligrams. So what is the base unit? The base unit is gram. Okay? And this is the prefix milli. So gram is the base unit. So this is a unit for mass. Okay? So this time, we're going to start at milli. Okay, from here. So from right to left. So we're going to move now to hectogram. This is hectogram. Okay, so move 1, 2, 3, 4, 5. So again, there are 5 places from right to left. So let us count now. So we have here, this is the understood decimal point. Understood decimal point. So we're going to move these 5 places. So 1, 2, 3, 4, 5. So the final answer is, we have 0.486 hectogram. Got it? Next. Suppose we have 0.369 kilogram to centigram. Okay, how about that one? 0.369 kilograms to centigram. So from kilo to centi again. So let us move again from kilo, then deca, the base unit is counted, then the deci, Then we have the centi. So still 5 places. So therefore, this is the decimal point. So move the decimal point to the right. So we have 1, 2, 3, 4, 5. Okay. So this is 3, 6, 9 plus 1, 2, 2 zeros. So add 2 zeros. So again, 1, 2, 3, 4, 5. So 3, 6, 9, add 2 zeros. So the final answer is 36,900 centigram. No more question. So in other teachers, they're using terminologies here. K stands for king, H stands for Henry, D stands for died, then the base unit by, deci, drinking, C, chocolate, M, milk. So again, king. Another example, 28 kilometers to meter. So multiply 28 with the value of kilo, which is 1000, multiplied by meter. So the answer is 28 times 1000 times meter is 28,000 meters. Next, 468 centigram. So multiply 468 with the value of centi, which is 0.01 or 10 raised to negative 2, multiplied by gram. So we have 4.68 grams. Next, convert 10 inches to centimeters. So this time we're going to convert British system to metric. But all we need is the conversion factor. So in 1 inch, there are 2.54 centimeters. So this is known as conversion factor. What about conversion factor? When we say conversion factor, it is a ratio that expresses how many of a certain or particular unit is equivalent to another unit. Say in 1 inch, there are 2.54 centimeters. Okay, so let us find out now. Copy 10 inches multiplied by the conversion factor. So this time we're going to write 1 inch in the opposite side. Okay, multiply 10 inches by this conversion factor. So write 1 inch in the denominator, and in 1 inch there are 2.54 centimeters. So cancel inch and inch. So we have now 10 times 2.54 centimeters divided by 1 is 25.4 centimeters. Okay, next, how about 100 meters? Okay, 100 meters to inches. So what is the conversion factor for this? In 1 meter, there are 39.37 inches. So again, the same process. Copy 100 meters multiplied by this conversion factor. Write 1 meter in the denominator and 39.37 inches in the numerator. Okay, so cancel meter and meter. So 100 times 39.37 inches divided by 1 is 3937 inches or 3,937 inches. Okay, next. How about 5 meters per second to feet per second? 5 meters per second to feet per second. So this time we're going to convert only meter to feet. So second will be as is. Okay, so what is our conversion factor? So in 1 meter, there are 3.28 feet. So this is our conversion factor. So let us solve. Copy the given 5 meters per second multiplied by the conversion factor. So we're going to write 1 meter in the denominator. Then in 1 meter, there are 3.28 feet. Okay. So cancel meter and meter. So 5 times 3.28. So we have 16.40 feet divided by s times 1 second. So 16.40 feet per second. So again, 5 times 8 is 40. So 0, carry 4. 5 times 2 is 10, plus 4, 14, carry 1. 5 times 3, 15, plus 1, 16. So there are 2 decimal places here. So 1, 2. So we have 16.40 feet per second. Convert 8 kilometers per hour to meter per second. So our conversion factors here are 1 kilometer is equal to 1,000 meters. 1 hour is equal to 3,600 seconds, because in 1 hour there are 60 minutes, and in 1 minute there are 60 seconds. So 60 times 60 is 3,600. So let us solve now. Copy 8 kilometers per hour multiplied by the conversion factor. Write 1 kilometer in the denominator, then 1,000 meters in the numerator. Multiplied by the other conversion factors. So 1 hour should be written in the numerator, then 3,600 should be written in the denominator. Okay, so what are the units to be cancelled? We're going to cancel kilometer, kilometer, R and R. What else? The number of zeros. So 2 zeros in here, then 2 zeros in the numerator. Okay, so 8 times 10 meters times 1 is 80 meters divided by 1 times 1 times 36 seconds. Okay, so 80 meters divided by 36 seconds. So the answer is 2.22 meters per second. Okay, next, how about 10 miles per hour? Let us change this to 10 miles per hour, 2 meters per second. So what are the conversion factors? So in 1 mile, there are 1.609 kilometers, but in 1 kilometer, 1,000 meters. So 1,000 meters multiplied by 1.609, so 1,609 meters. So these are the conversion factor. The same, 1 hour is equal to 3,600 seconds. Okay, so let's solve now. Copy 10 miles per hour multiplied by, in 1 mile, write 1 mile in the denominator, Next, 1609 in the numerator. 1609 meters multiplied by 1 hour is equal to 3600. So we're going to write 1 hour here in the numerator, then 3600 seconds in the denominator. So let us cancel now mile and mile, hour and hour. What else? How about the number of zeros? So let us just cancel 1 0, since there is only 1 0 available in the numerator side of the equation. Okay, so we have so 1, this is 1 times 1609 meters times 1 is 1609 meters. Again, 1 times 1609 meters times 1 is 1609 meters. Divided by 1 times 1 times 360 seconds. Okay, so 360 seconds. So what is the final answer? Okay, so we have 4.47 meters per second. So this is the final answer. Next, for density, supposing we have 20 kilogram per cubic meter to gram per cubic centimeter. So the same, we're going to convert 2 units, kilogram to gram, then cubic meter to meter. Okay, so what are the conversion factor? 1 kilogram is equal to 1000 grams. 1 meter is equal to 100 centimeters. But as you have noticed, we're expressing volume to cubic meter, so therefore we have the raises to 3 raises to 3. So 1 meter times 1 meter times 1 meter is 1 cubic meter is equal to 100 cm times 100 cm times 100 cm is 1 million cubic centimeter. Okay, so these are the conversion factors that we're going to use. So let us solve. So copy 20 kilograms per cubic meter multiplied by, okay, kilogram first. So write 1 kilogram in the denominator, 1000 grams in the numerator multiplied by another conversion factor. So write in 1 cubic meter there are 1 million cubic centimeters. So we're going to write 1 cubic meter in the numerator, then 1 million cubic centimeter should be written in the denominator. So what are the units to be cancelled? Kilogram, kilogram, m cube, m cube. How about the number of zeros? So we have three zeros here. We have 3. What else? We have 20, so we can cancel another 0. 1 0 in here. Okay, so we have now, we remain 2. So 2 times 1 gram times 1 is 2 gram. Again, 2 grams. 2 times 1 times 1 is 2 grams. 1 times 1 times 100 cubic centimeter, 100. Then we have here cubic centimeter. So 100 cubic centimeter. Okay, so 2 grams divided by 100 cubic centimeter is equal to 0.02 grams per cubic centimeter. Okay, again, 2 times 1 gram times 1, so 2 grams, divided by 1 times 1 times 100 cubic centimeter is 2 grams divided by 100 cubic centimeters is equal to 0.02 grams per cubic centimeter.